everyone, hello and welcome back to the Astro Athens channel. I realize this is a really weird angle, but that's because this is one of the videos from the original series, so I figured why not. I'm here at one of my favorite parks to explain some astrophysics to you guys. So the reason I'm sitting down here is because I've got some sidewalk chalk and the sidewalk behind me, so this way I can actually visualize for you guys what I'm going to be talking about. So I'm going to be talking to you all about something known as fast radio bursts. Now, I actually did an earlier video on what FRBs actually are, so I recommend watching that one first before continuing with this. But this one is specifically on a whole new study and discovery from a fast radio burst known as FRB 181112. So what's cool about this one is it was detected bursting out of a galaxy, passing through the halo of another galaxy, and then us being able to detect it here on Earth. And this is bizarre because we've never been able to detect a fast radio burst going through the halo of another galaxy. Now this is where my nice illustration skills come in, because you guys probably don't know what the halo of a galaxy is, and for those more advanced on my channel, maybe you do know what the halo of a galaxy is, but I'm going to draw it out for you. So we're going to start with the center of the galaxy, which is where the supermassive black hole is located. And then right around it is where you have a lot of the stars that are accreting, known as the accretion disk, the event horizon's right there. But when you see it from far away, there's actually the galactic bulge. And this is where the majority of the stars are actually orbiting around the supermassive black hole. This is an area where there's the strongest amount of gravity, and so you have all the stars coagulating in one area. And then you have the rest of the other stars that are like orbiting around the galaxy. For instance, in the Milky Way galaxy, you have spiral arms. And to kind of relate to our own galaxy, the sun is actually located right about here, we'll say. It's actually in one of the furthest out arms. And then when we zoom out even more, you then have these regions outside of the disk where there's collections of stars. These are known as globular clusters. They're literally clusters of stars. And then just beyond that, you have the halo of the galaxy. Now this is a very, very spread out region outside of the galaxy itself. Like I said, you have all the stars here, you got the spiral arms in the disk, and then you've got those globular clusters, and then you have the halo. Now what's so fascinating about this study is that the fast radio burst, which we're going to use the white chalk to represent it bursted out like here. Fast radio burst. So that's normal, where you'd be able to see it, where it bursts out of the galaxy. But what's even weirder is, now let's zoom out a little bit more. So you have this fast radio burst that just exploded out of the galaxy, but it was so powerful that it actually then passed through the halo of another galaxy. So we're going to say this is the same diagram: supermassive black hole, galactic bulge, and then you have the disk of the galaxy, and then you have the globular clusters, and then you have that halo. It was so powerful that the fast radio burst passed through the halo, and then it passed through the halo, and then we were able to detect it here on Earth. Here on Earth, within the Milky Way galaxy, which is just insane that that was even possible. Well, the reason this fast radio burst is so cool that it was detected is not only is the first time that we've been able to see a fast radio burst passing through the halo of another galaxy and then us being able to see it here, but also because fast radio bursts tend to have multiple pulses, and most of the time the pulse lasts for only about 40 microseconds. That's 10,000 times shorter than the blink of an eye. 40 microseconds. That's 10,000 times shorter than the blink of an eye. So the fact that we see this so many times and passing through the halo of this galaxy, it's giving us a lot of information of what's actually happening in that halo. Now, what we ended up finding out, for one, is that the halo extends to 10 times the distance beyond the stars in the disk of the galaxy. So you got the disk of the galaxy, and then 10 times beyond that is actually where the halo is located. Now, this isn't really to scale, this is just for demonstration, but we were able to detect that it's extended 10 times out beyond where the actual stars of the galaxy are located. and yet it's still gravitationally bound to that supermassive black hole in the center of the galaxy. Now this tells us a lot about the magnetic field in the halo of the galaxy specifically. And the reason this is so important is because the more we can learn about how active our universe is, the more we can understand just how much energy we potentially can maybe harness one day, hypothetically. And what they actually found was that the halo of the galaxy itself, the magnetic field, is about 1 billion times weaker than your refrigerator magnet at home. And to me, that's actually really fascinating because that's not powerful at all. It's like actually really weak. Because so many times the magnet on my refrigerator has just fallen off because it's, I don't know, it gets weak after a while. So it's fascinating that the haze, that the circumgalactic medium found in this area of the galaxy has such a weak magnetic field. So why is that? Is it because it's not as, close to the supermassive black hole? Is there's not as much energy from all the stars in the disk? So the more that we can understand this and how it is that our fast radio burst exploded from one galaxy, passed through another, and was detected here on Earth, it can lead us to a better understanding of the future, of possibly more galaxy collisions, or what the future holds for our galaxy. Last thing I'm going to leave you guys off on is actually the researchers behind this study, because I think it's really important for us to recognize that it's a worldwide effort, that countries all over the world are coming together for space exploration and to discover new things about the cosmos. And it came out actually out of Australia. I'm going to read off the paper because it's a really long acronym. It's CSIRO ASCAP radio telescope. That actually is the Australian Square Kilometre Array Pathfinder Telescope. Really, really long name. And the CSIRO is actually a program. It's an organization called the Commonwealth Scientific and Industrial Research Organization. And it was first discovered actually out of Australia. And what they did was they combined radio images from this radio telescope in addition to the Very Large Array, VLA, and they were able to combine optical images with radio images, overlaying them on top of each other to detect this fast radio burst. And they were able to see that it really was such a powerful fast radio burst, and that it was able to actually travel light years throughout space and pass through this galaxy. And I mean, honestly, if that's not cool, I really don't know what else is. And what's cool is this research really ties in with a couple other studies being done right now on halos specifically of galaxies. One of them actually was just published on September 26th in the journal Science, that was studying like the very neutral type of environment that's found, and very calm and tranquil environment in the halo of a galaxy. Well, that about wraps up my adventure out here. I'm drawing on the sidewalk all of the different galaxies and talking about fast radio bursts. I hope you guys enjoyed this study as much as I did, and stay tuned. I'm going to be doing a new episode on Cafe Astro Athens. All right, thanks for watching, guys. Leave a comment, let me know what you think about fast radio bursts, or if you guys actually study galaxy evolution or the deep cosmos or cosmology. Let me know. I love reading your comments. All right, bye guys. Bye.